Okay folks, we're going to do some exponential equations today, and we're going to use logarithms actually to solve these. So they look different from our log equations, but we're actually going to use similar steps and use logarithms in our solution, so that's why we're working on these right now. These, by the way, are fairly common on the SAT. You've probably seen these before on some of your practice tests. So our move for solving these, here's an example of what they look like here. Our move for solving these is going to be to get a common base. Okay, so what that means is right now I have 2 as my base on the left and 8 as my base on the right. I want them to be the same. Okay, and the way we're going to do that is we're going to figure out which number is a factor of both of them. So we want to write each side as a power of the same number. To do that, we're going to use the fact that 8 is really just 2 times 2 times 2, right? Because 2 times 2 is 4 times 2 again is 8. So that's the same as saying 2 to the third power. Okay? So I'm going to use this fact to get a common base. So the left side I'm going to leave the same. The right side I'm going to say is 2 to the third power to the 5th power. So notice because 2 to the third is the same as 8, I can replace 8 with 2 to the third here. Now I have the same base on both sides. I have a 2 on the left, 2 on the right. Now I need to think about my exponent rules. So what I do here is I multiply them. Power to a power. You multiply our powers. Now I have a common base and simplified exponents. And what I'm going to do here is I'm going to take the log now of both sides. So log base 2 of the left and the log base 2 of the right. And what happens is that cancels with my base, right? And what's left over is just the exponents. X plus 3 equals 15. And then that's a very easy problem to solve then, right? It equals 12. Okay. So once we've gotten a common base, we're going to take the logarithm of both sides. And what that actually looks like in practice is we can, I should say, set the exponents equal to each other and then solve. Okay. So those are our moves here. We'll do one more easy one, and then we'll tackle a kind of a scarier looking one down here. All the same steps though. So here, what I'm looking for is a common base. And I should notice right away that 81 is really just 9 squared. So I can replace 81 with 9 squared, and then I have 2x plus 3 is still my exponent here. Okay, so now my base is the same, and same thing, I'm going to multiply my powers on the left to get rid of the parentheses. I have 9 times 2, and I'll just use parentheses here to represent that I'm multiplying these. Now my bases are the same, I have 9 on both sides. And again, we get something that you guys can solve in your sleep. Okay. Easy enough, right? So again, we're getting a common base and then setting the exponents equal to each other. Now is a great time to pause, capture this example in your notes, and make sure that you can understand how I did each step. Okay, now our last one here. This one is hard, particularly just because it's hard to figure out what the base is, right? So here's how I might check on my calculator. And it's a little bit of guessing and checking. The better you are at just your multiplication facts, the easier this will be. But what I could do is I'm going to guess a number that might divide into these. So 2/16 seems like it's divisible by 4 to me. So I'm just going to guess that might be it. That might be the base here. So I'll divide by 4. I get 54, and I'll divide by 4 again. And notice I get a decimal. Okay. So what that means is I can't just keep multiplying 4s together and get 2/16. If I try again, I'll try 2. And then I'll divide by 2 again. And then 54, so far so good. And now I'm going to get a decimal again. So that tells me that 2/16 is not a power of 2. We'll try 6. So I get 36. And then I divide again, I get 6. And then I divide again, and I get 1. So what I can do, right, if a number is a base of my base, I can divide by that number over and over all the way down to 1, right? I did that 3 times, so that tells me that 216 is really 6 to the third. Replace that. Okay. So again, I'm doing a little bit of guessing and checking. And then now I'm going to check 6 for 1296. Because these are nicely designed to work out for you, this should work. So 216, 36, 6, and 1. Okay, oops, I meant to type divided by 6, gives me 1, right? So that tells me now, I did that 4 times, so that tells me 6 to the 4th is 1296. Okay, so you can use your calculator. You guys understand exponents well enough to kind of guess and check like that. But you can use your calculator if you get bases like this that are bigger and harder to figure out. Now I have common bases. I just brought my exponents down, and I can just rewrite now. So I can say it's 3 times 3x plus 3 equals 4 times 2x plus 5. And again, that becomes an equation that you guys can solve in your sleep. Okay. So as always, make sure you come back to the video if you get stuck. Make sure you have good examples captured in your notes. And let me know if you're on the struggle bus.